Today's lab is to figure out the type of carbohydrate in an unknown carb sample, such as honey. Does anybody know carb that is in honey? But what category is sugar? Sugars can be different types. What about lactose? Powdered sugar? Wheatgrass seeds. So throughout the room, there's a bunch of different carb types to sample. There's some more over here too. So I'm going to teach you a lab technique that you can use to determine the type of carbohydrate in each unknown sample. Okay? You can see from your sheet, we're going to be using what tests?
The Benedict test.
Benedict and iodine. So let's walk through this protocol together and think about a logical way to go through this experiment. So we're going to be doing a Benedict's test first, right? So Benedict's is blue. This is Benedict's. From the protocol, how many milliliters of Benedict's should I add to my sample? 3. How many milliliters of my sample should I have?
3.
Okay, so we're gonna take glucose. Okay. So I'll add 3 milliliters of glucose. This is the same protocol you're going to use. So I have my 3 milliliters. I add how many milliliters of Benedict's? 3? What am I supposed to do after adding the Benedict's?
Stir.
Stir it? Is that what the protocol says?
3 milliliters of carbs. Why did you say boil for 5 minutes?
Boil for 5 minutes. So you come over to the hot plate. Hot plate is on. Just give me one characteristic of a hot plate.
Hot.
It's hot. You bet it is. You have to be careful when you put it in there, but you're careful enough that you don't stick your hand into the hot water or onto the hot plate, right? So please use some common sense. That's good enough. So that sample is in being heated. We heat it for 3 or 5 minutes. What are we looking for as a result? Say I pull that out of the hot water and it's still blue. What does that mean to us? Check out your protocol. It's right on there.
It's not have monosaccharide.
Your carb has no monosaccharides if it stays the same color. What if there's a color change to orange?
It's
have
hard
monosaccharides.
The sample then is made predominantly of monosaccharides. You see how that works? Okay. Now, simultaneously, we're going to run another test. Depending on what you get here, you're going to use that information alongside the iodine test. The iodine test is telling us what?
It's a polysaccharide.
So it's a test for polysaccharides. Well, what would you hypothesize given what you know about what we're testing, that being glucose?
Polysaccharide.
Glucose is a polysaccharide? It's a monosaccharide. So we're going to do this polysaccharide test on it using iodine, but what are you betting? You're probably betting there's no change, right? Your hypothesis would be, in those 2 experiments, that you get what? Tell me what you're hypothesizing you would get for the iodine test, which tests for polysaccharides, Jack. You're predicting no color change, and in fact, I'm 3 milliliters in here, and it's still yellow, right? Right? Iodine is initially yellow. Our sample still remains yellow as we add iodine to it. So that's a negative result for iodine and glucose, which we predicted, right? We expected that because glucose is what type of sugar? Yeah. It's a monosaccharide, right? So that's predictable. We set this in here as blue. What is it now?
Brown.
It's a brownish red, right? So is that a positive or negative result for monosaccharides?
Positive.
Yeah, it's a positive result, a positive change. So your experiments have told you the following with respect to glucose. Yes, it's a monosaccharide. No, it's not a polysaccharide. So your conclusion should be that glucose is what? What type of carbohydrate? A monosaccharide. Okay? Now I want to show you what will happen if you expose iodine to a polysaccharide. So what's something that we could use really quickly as a good indicator for being a polysaccharide? Look on the board there at our review and tell me what's an accessible polysaccharide. Yeah, starch. Guess what I have here?
Starch.
Potato starch. Potato starch. It's really gross. It looks like this. It looks cloudy, but there's actually chunky potato starch in there. Right? There's so much of it in there that it's precipitated. All right, so I'm going to take how many milliliters of this? 3. By the way, this is the same protocol that you'll be using. Okay? So you take 3 milliliters of starch. Okay? What color is that? Yeah, it's like a clearish white. And when I add the iodine, what are you hypothesizing will happen? It will change color, and your protocol actually tells you what color it changes. So somebody check on the protocol. It should turn black, right? Because it's loaded. We already know that it's loaded with polysaccharides. Starch is polysaccharide, right? So watch this. As we add it, do this for our friends at home. Look, you guys see it? It's actually kind of a cool result, right? Change black. So it's like a bluish black here. But definitely a positive result for polysaccharides, right? That's an easy result to see. So I'm going to challenge you. You guys are a smaller group, so we can do maybe 5 unknown carbohydrate samples. You flip your lab over on the back. There's a table for you to fill out. There is hypothesis, result, and conclusion also on the back there. I'd like for you to fill that out for all 5. So what do you think molasses is as far as a type of sugar? Do you predict that it's a monosaccharide, a polysaccharide? What is your prediction? Then, what result did you get? And what can you conclude from your result? Okay?
If we wrote down
Yeah. No, you can use the extra spaces. There's an extra space there. Is everybody clear on what we're doing? We have the rest of the class, which is, a good 45 minutes. Before you get up, I need to tell you where some of this stuff is. Okay, let me pause this.